All right, so we should be right here where it kind of switches gears and we start talking about adding and subtracting instead of multiplying and dividing. Adding and subtracting requires a little bit more work because remember when you're adding or subtracting fractions, you have to have like denominators. So if you don't have those, you can't do anything until you get them to have like denominators. Multiplying and dividing is easier because you don't need common denominators. All we had to do, like what we even just saw in our bell ringer, is you have to just simplify, factor your expressions and then just cross things off. It's not quite as simple when we're adding and subtracting. So we will still want to factor our denominators because we want to be able to see those kind of smaller pieces, and then we'll compare. Is there anything missing from either denominator that the other one has? Because whatever maybe you need to add on is going to help us get to those common denominators. So I'm going to factor my denominators completely. Then I'm going to look to see what's missing from my fractions, like if I need to add something to one or maybe even both of them. And then I'm just going to do them in multiplying. But then we'll have to make sure that we also take that times on whatever's on the top. Because you would do the same thing if you had fractions like, if you had something like 2/3 and you were trying to add that to 5/7. You'd have to start by trying to figure out what can I do with the denominators to make them look the same. And then whatever you do to the denominators, you have to do to the numerators as well. So like for this one, if I'm just thinking about numbers, 3 and 7 can both go into 21. And to do that, I'd have to take the first fraction times 7 and the second fraction times a 3. And again, we would do that on the top and on the bottom. So we're going to be doing this process, but it's not just going to be numbers like that. It's going to be expressions with these polynomials. All right, so let's take a look at one coming down here. First thing I'm going to do is try to factor. So I don't see anything I can factor on the numerators, so I'm going to go ahead and just focus on my denominators here. How can I factor this x squared minus 10x plus 25? Okay, so I'm just going to write that underneath it here. And then how can I factor the other side on the bottom? Good. Okay, so now we compare our denominators. You need all the fractions to have the same pieces. And so if something is missing one, we just have to multiply that side by whatever it's missing. So in this case, I notice that I have a couple of x minus 5s. Like these are in common. Okay, so they each have at least one of those. But the first fraction has another x minus 5. So I'm going to have to add that to my second one. And the second fraction has a 2. And so I'm going to need a 2 on the other one. So I'm just thinking right now, my least common denominator, or my LCD, is going to be 2 and then x minus 5 twice. So I'm just writing that out so I can kind of see I need the bottoms to look like that before I can do anything here. And now what I'm going to do is try to make sure that I get there. So with my LCD, I'm going to take this expression. I'm going to rewrite it down here. So I'm going to take that x and put it over x minus 5, x minus 5. Okay, but then what I'm going to do is put brackets around this. And I'm going to multiply that fraction by my least common denominator. So I'm going to now take this whole piece I wrote up here in the blue, and I'm going to put it right here. 2 times x minus 5, x minus 5. Okay, then what I'm going to do is on the other fraction, so I'm going to bring down the minus sign because that was from up here. Again, in brackets, I'm going to write out what we said for simplified. So x minus 4 all over 2 times x minus 5. And then again, we're going to take that times 2, x minus 5, x minus 5. Okay. What I'm going to do next is I'm going to kind of combine a couple of steps here. So ideally, I know that the bottom should say 2 and then an x minus 5, x minus 5. I know that's what my bottom should look like all the time. But then when I think about what's going on the top portion, if there were things that were in common on my denominator and what I was multiplying by, they would essentially cross each other off. So what I mean is on this first one, I have an x minus 5 up here and I have them down here. You guys following me so far? What does the bottom not have that I'm multiplying by? A 2. I'm going to take this 2 and I'm going to multiply it in to the top. So I'm going to take 2 times that x. I'm just going to write it as 2x. Okay, I'm not going to worry about these x minus 5s because I'm imagining to myself right now like these would both just kind of cancel off with the bottom. But remember, my entire denominator here has to still have that LCD. So the cross-canceling only happens when I'm trying to multiply with my numerator. It does not just eliminate that bottom completely. So I'm going to go ahead and just write down here 2 times x minus 5, x minus 5. Like so. I'm kind of simplifying the process a little bit by not having to write out these fractions multiple times. I could go about this a long way, and I could write, 2 and distribute that to the x, and the x minus 5s, I could distribute that to the x2. I just don't think that's worth our time doing because you're eventually going to have to undo that and cross things off. So I'm trying to save you guys a little bit of time here and a little bit of that headache. So now if you look at the second fraction, what do they have in common from the denominator and when I'm multiplying? What can I cross off? I can cross off an x minus 5 and a 2. So on the top then, I'm taking that x minus 4 times the x minus 5. Now I'm not actually going to multiply them together. I'm just going to write them side by side for right now. So I'm going to do minus, because there's a minus sign here. So that goes right there. And then x minus 4 times that x minus 5. Again, still all over 2 times x minus 5, because that gets me my subtraction to happen on just the numerator. My denominators stay the same. Just like when I had a fraction up above with those numbers, after you got them to look the same, you're really only operating with your numerators, and your denominator just carries over across the entire answer. You don't actually add or do anything with your denominators. Okay, so now if you think about simplifying this, let's go ahead and FOIL this x minus 4 and x minus 5. So I still have this 2x minus, if I FOIL that, what would that come out to be? What would be your first term? X squared minus 5x. Okay, so I want to just stick those together right now. What would the minus 5x and the minus 4x together become?
Minus 9x.
Good, minus 9x. And then what's the last term? Plus 20. Again, still all over 2 times x minus 5, x minus 5. Okay, last thing is just to try to simplify your numerator, put it in standard form in that descending order. Also, just keep in mind, there is this minus sign here. So this is really going into the parentheses for all the terms, and it's going to affect all their signs. So it's just going to switch everything. The first thing I would do is, I know I have an x squared. That's going to go first because I'm putting it in descending order. But because there's that minus sign, it's going to switch it to negative. So that x squared becomes a negative x squared. What happens to the negative 9x? Plus 9x. Can I combine that with the 2x up here? So what's 2x plus 9x now? 11x. Okay, that takes care of most of these terms. The last thing I have here is that 20, but it becomes negative because of that minus sign. So I'm going to write minus 20. And then my denominator is still 2 times x minus 5, x minus 5. That's your final answer. That's as simplified as we're going to be able to get that. So on the top of the next page is one for you guys to try. So I'll give you a couple minutes. Go ahead and do what you can with it. Okay, I've kind of got it started up here. I factored my denominators. I wrote out over here what your LCD is just so we can kind of remind ourselves that's going to be in the bottom of my fraction all the time going forward now. And then I'm taking my fractions times this LCD. So I'm going to go ahead and just, instead of rewriting it all out, I'm going to just do it up here. So I was putting brackets around those. And I'm going to just put on this one on the left. And then this one I'll put on the right. There's no harm in rewriting it all down. I'm just trying to save a little bit of time here. So then if I look for this first fraction, the x plus 5 and x plus 6, they're gone. So really I only need to take the 1 times the 3. So that just becomes 3. This time we're adding. So I'm just going to bring that plus sign down. Over here on the other side of the other fraction, the 3's and the x plus 6 cancel. So I'm taking this 3 times what's left over here, which is that 3x plus 5. And I am going to distribute that. What would be 3 if I distribute that into the x plus 5? What does it become? Good. 3x plus 15. And then again, my denominator says 3. And then x plus 5, x plus 6. Okay, what's the last thing that we could do here? Well, maybe not truly last thing, but what would be the next thing we could do? Can you combine anything on the top? What's that become? So I'm going to rewrite this as 3x plus 18. Okay, can I simplify that though? Yeah, I can refactor this so it's 3 times x plus 6. What do you guys think we can do here? We can cancel stuff off. So what can I get rid of? Yeah, the 3's are gone, the x plus 6's are gone. So what's left on top? A 1. Good, not 0. Okay, just because we got rid of everything doesn't mean that it goes away. There's still a 1 there because you're dividing by itself. And what's left on the bottom? Good, x plus 5. The last one we did, we weren't able to do that because the polynomial that we had on top, we weren't able to factor this way. But this one we were able to. So we just took it one little extra step. We were able to kind of clean it up a little and just even make that answer even more simple. Questions on that one? Okay, this last piece I have here, guys, is going to combine what we've talked about in this whole section. So we're going to be adding and subtracting and multiplying and dividing. These are called complex expressions because they are like one fraction and then the numerator and the denominator are sometimes made up of other fractions. So there's a lot of things happening in these kind of problems. So what I mean is if you look at this first example here, it's asking how many rational expressions are in this. Well, this is a rational expression, so there's 1. This is another one, so there's 2. And technically 7 is rational because I could write it as a fraction. There's actually 3 total rational expressions in this problem. That's why it's called a complex, because we've got a lot of pieces that we're working with here. Let's focus on just the numerator for right now. So the numerator says 1 over x plus 7 minus 1 over x. So this is like what we were just doing. What would be my LCD for this expression? Good. We need an x and we need an x plus 7. Okay, so let's just handle the top for a minute because I want to try to get this together. So let's take the first half times that LCD and the second fraction times it as well. All right, on the first fraction, the x plus 7's are going to simplify, and I'm going to take x times 1, so that just becomes x. Then I bring down my minus sign. Over on the second fraction, my x's are gone, and I'm taking this 1 times the x plus 7, which is just going to be x plus 7. But I'm putting it in parentheses because that minus sign is going to affect all the pieces that are in that parentheses there. And then my LCD on the bottom is just x times x plus 7. Okay, so let's think about what happens on the top here. I'm just trying to simplify. Remember, this minus sign is going to go in to the x and into the 7. So really, what happens with your x's on the top? They cancel because it's x minus x. So those are gone. What am I left with on the top? Well, no more x, right? We said the x's are gone. But minus 7 is still there. And then on the bottom, we have x times x plus 7. Okay, that handles the top portion. But remember, it said up there that top was also divided by this 7. So really, we're taking this expression divided by 7. Or you can think of that as 7 over 1. What did we do last week, though, on Friday? Anytime we saw division, what did we do? Multiplied by the reciprocal. Okay, so I'm going to just rewrite this. Negative 7 over x times x plus 7. I don't do anything to the first fraction, but I'm going to change that to a multiplication sign and write it as 1 over 7. Then I look, is there anything we can cross off here? Can I reduce the 7's? Yeah. So this is just a negative 1. And then that other fraction just goes out to 1's there. So what's my final answer here? There you go. All right, last one we have for today. and it's still doing what we just did. It's combining the adding or subtracting and then the multiplying / dividing that we have to figure out. So this one's even more complex. How many rational expressions are in this one? There's 4. Okay, so let's think about just the top for a minute. What's your LCD of the top part of the fraction? 3x. Good. X plus 2. What's the LCD of just the bottom? Good. X and x plus 2. Just like I did on the last one, I'm going to kind of focus on them individually and try to simplify as much as I can before I even try to put them together totally. So for this first set of fractions, I should say, I'm going to take both of these times that LCD. Okay, so this top here, the 3 x's are going to go away. And I'm going to take x plus 2 times 7. Or you can take 7 times the x plus 2. You're going to distribute that. So it should become 7x plus 14. And then there's a plus sign connecting these fractions here. On the second one, the x plus 2's cancel. And so I'm taking 1 times the 3x, which is just 3x. And that's all over 3x times x plus 2. How can we simplify the top here? What can we put together? 7 and 3, so it's 10x plus 14 all over 3x times x plus 2. That's for the top. Now we have to do the same process for the bottom. And then we'll have to take our simplified expressions and we'll have to work with them to finish it. We can, if you want to do that right now, you could rewrite this as 2 and then 5x plus 7. You can do that now. If you wanted to wait until you were working with the 2 fractions to do the dividing, that would be fine too. But yeah, I'm good if we go ahead and just simplify it right there. Okay. Now let's do the bottom. So same thing down here, but my LCD this time is x times x plus 2, and there's a subtraction sign there, so we'll just have to really watch our signs on this one. Okay, so for this second one, the x plus 2's on the first fraction are gone, and so I'm taking x times 2, which is 2x. And then there's a subtraction sign, so minus. On the other one, we're going to cross off the x's, and you're taking 5 times the x plus 2 quantity. So 5x plus 10. And I'm putting that, again, in parentheses because there's a minus sign sitting in the front. That's going to have to impact both of them there. And then that is all over our LCD, which we said was x times x plus 2. How is the top of that going to simplify? What would be your 2x minus 5x? Negative 3x. And then, is it plus 10 or minus 10? Good, minus 10. I don't think there's anything we can do with that as far as taking anything out. So now the last thing we need to do is we're going to take this, we're going to take this expression here, and we're dividing it by this expression here, because that's what we had up in the original problem. So I'm going to keep the first one as is. So 2 times that 5x plus 7. But then if I go to a multiplication sign, you have to flip that second fraction upside down. So the x plus 2 goes on the top now, all over negative 3x minus 10. Can we cross anything off?
Next question.
X plus 2's. Do you guys see this x here? And the 3x down here? Could we simplify the x's and just get rid of those? Like this one and this x could cancel. You could do that. I think that's it, though. So what are we left with on the top?
2, 5x plus 7.
One more thing on the bottom. That's right. If you want to leave it there, that's fine with me. If you wanted to distribute the numbers in, like 2 times the 5x plus 7, 3 times the negative 3x minus 10, that would work too. But I'm okay with us leaving it here for now because that's kind of what we've been doing with our other answers, just leaving them in their factor form. Questions on that process? Those ones I think are the most intense because you have to do a lot of work there because it's combining everything that we talked about individually.